So now that we know what a species is and how we're going to group species, we need to think about species diversity itself. So now that we know what a species is, we want to think about what makes an area have a higher species diversity versus a lower species diversity. So I want you to pause the video and tell me which of these two areas, one area, two areas, has the highest species diversity. Okay, so most people would say this one on the left. Now, how about this one? Which one do you think has the highest species diversity? Now, the answer is actually this right one in this case. So how did you decide? In the first one, you probably counted up the number of different things. And I'll go back here real quick. So in this one, you probably said the one on the left has more diversity because there are more different kinds of things. So there's a puffin and a blue butterfly on this left side, but it's not over here. So that would tell us that there are more different species in this box, so higher species diversity. In this second one, you'd probably say on the right because there's more even representation of the different species. So on the left, it's really dominated by ants, and over here, there are less ants and more other things. So we would say that this right has more species diversity. So the number of species is called species richness. So in the first one, the one that had higher diversity had the highest species richness, number of species. The second one, the two blocks had the same species richness because they each had the same number of species, but the one on the right had more evenness, which means the number of individuals in each species were more balanced among the species in the more diverse one. So we call this evenness. It's the distribution of individuals among the different species. If it's very biased towards one species, then the species diversity is lower and the evenness is lower. If it's more even across the different species, then it has higher evenness and higher species diversity. And species diversity includes both richness and evenness. So some people have created different species diversity indices to come up with and include richness and evenness in a single metric so that you don't have to have two different numbers and compare, like say, this area has high species richness but low evenness. This other area has high evenness but low richness. How do we compare those? So they've come up with a single measure that we can look at diversity overall and incorporate both species richness and evenness. So to use this index, you need data on the abundance of each species, so the number of individuals of each species in an area. And basically, if there are more species or it's more even, you get higher diversity values, and less species and or less even means lower diversity. And so here, the P's are the proportion of individuals to the total for each species, and you sum it up using this equation. And this is just to show you how it works. I'm not going to expect you to calculate this out, but I do want you to know basically what it does. And most commonly, we use the Shannon Diversity Index, which is the one illustrated here, but there are multiple different indices that have been created to do this. So basically what you do is we have these 5 different species of fish here, and they've counted up the number of individuals in each pond to create this metric. And so you can see it takes the number of each individual divided by the total. So it's the percent of that species in the total. And so they've conveniently made the total number of fish here 10, so that 6 out of 10 for this one is the proportion in the sample, and then each other one is 0.1. And they take the log of p and the log of p times p, and they sum it all up and make it negative, and you get that the index, which is h, is 0.53. Over here, the second pond, we can see there's the same number of species, or the same number of individuals of each of the 5 species, and there's still 10 fish. So each one, the proportion is 0.2. So they took the log of that number, they took the log of that number times p, and they added it all up and then made it negative, and here you can see the index h equals 0.7. And so you would have guessed, just from what I've already told you, that this second pond has higher species diversity than the first pond, and then these indices reflect that. So h equals 0.53 is less than h equals 0.7. So we would see here how this works, and the second pond has the higher species diversity. So there are a few different metrics of species diversity. We have alpha diversity, which is the number of species within a single habitat patch. We have gamma diversity, which is the number of species in a large area consisting of distinct habitats or patches. So we have regional species richness. So you might think of alpha diversity as the number of species or the diversity of species within a single pond. The gamma diversity would be, if we looked at a region that has many ponds, it's the total number of species of fish in all the different ponds in a larger area. And then beta diversity looks at the turnover of species between individual habitats or patches. And this is actually a little bit confusing. So it's gamma diversity divided by alpha diversity, but we can think of it as the turnover of species among these different ponds. So if all the ponds in our region had roughly the same kinds of species in them, then it would have low beta diversity because there's not really a difference. If each pond had a separate group of fish in it, its own kind of fish assemblage, then there would be really high beta diversity. So I'll show you another example here. This is mountains, so we have species on a mountains. These might be little wildflowers that each live on top of the mountains. And so here in region 1, we see that alpha diversity is 6. So each mountain has 6 species on it. The gamma diversity is 7. So there's a total of 7 species of wildflowers across all 3 of the mountains. So the gamma diversity is the whole region, and all 3 of these mountains are in the same region. And the beta diversity is 1.2. So that's pretty low. It means that most of the mountains share the same species, though they're not exactly the same. Region 2, the green region here, has lower alpha diversity. So on average, there are only 4 species on each mountain. The gamma diversity is higher, meaning that if you look at the whole region, there are more different species. And the beta diversity is higher than the first one. In region 3, we have lower alpha diversity, so there are fewer species per mountain. The gamma diversity is 8, and we get the highest beta diversity. And that's because each mountain has almost completely different species on it. And so the beta diversity is the highest here because there's very little overlap in species that occur from one mountain to the next. And so that illustrates the differences between alpha, gamma, and beta diversity. So alpha, again, being the number of species in a particular area. Gamma diversity is the number of species on a regional level. So multiple ecosystems are included in this. Not multiple types of ecosystems, multiple ecosystems. So multiple mountains, multiple ponds, something like that. And then beta diversity looks at how unique the group of species is across the different areas.